Okay, so hi guys. So now that we did, so in the last example we did a basic quadratic inequality where it was already factored, and now what we're going to do in this example is we're going to look at an inequality where it is actually in standard form and we have to factor it. So it says solve the inequality and state your answer in interval notation and graph on the real number line. So basically we have something like this: negative x squared plus 7x plus 18 is greater than or equal to 0. The one thing that I want to state here is there is a negative leading coefficient. So if we do divide by a negative number, we need to change the inequality symbol. We need to flip it over. So we have negative x squared plus 7x plus 18 is greater than or equal to 0, right? And if we divide by negative 1 on both sides, this will be x squared minus 7x minus 18 is less than or equal to 0, okay? So it's literally going to flip over because we divided by a negative number. So now this is our new inequality, and now all we have to do is factor it. So if you guys don't remember from algebra or from your class, we always said that we have ax squared plus bx plus c equals 0, right? And when we factor this, we want two numbers that multiply to a times c and add to b, right? And I'm going over this because if you guys don't understand how to do it at the top of your head, how to factor, then I'm going to show you how to factor this out. So the numbers that we have are, so we know that a is equal to 1 in this inequality. A is equal to 1, and b is equal to negative 7. So, and then also c is equal to negative 18. So a times c, if I just kind of do this, a times c is going to be 1 times negative 18, right? So times negative 18, which is negative 18. And then b is negative 7, right? So b is negative 7. So I want two numbers that multiply to negative 18 and add to negative 7, right? So if I do my factors of negative 18, I have negative 1 and 18, negative 2 and 9, negative 9 and 2, right? And out of all of these, the one that adds up to negative 7 is going to be negative 9 and 2. So really, I can rewrite this inequality, or this quadratic expression, as the quantity x minus 9 times x plus 2 is less than or equal to 0, right? So that is my new inequality. And now I have to, we have to basically state the x-intercepts. So when we actually solve for x in this equation, when we make it equal to 0, we get that x minus 9 equals 0, or x plus 2 equals 0. So then if we solve these both for x, we get x equals 9, and then Here we subtract 2 on both sides, and we get x is equal to negative 2, right? So then what I'm going to do is I'm going to make a number line. So we're going to go ahead and make a number line with the endpoints at negative 2 and 9, right? So let me just kind of go ahead and give me 1 second, guys. So here I have the number line, and I'm gonna label the points negative 9, or I'm sorry, 9 and negative 2. So negative 2 we're gonna have right here, and because it's less than or equal to, we have to make it a closed dot, right? And then for x equals 9, we have it all the way over here, so it'll be right here, right? So now I want to pick up numbers. So now here's negative infinity, and then it goes from negative infinity to 9 to negative 2, right? So this is basically this portion from negative infinity to negative 2, including negative 2, right? And then it goes from negative 2 to 9 right here. So this is another portion, right? So this is another portion. And then it goes from 9 to infinity, which is yet another portion. So you can go like this, where this is infinity, right? Infinity just means it goes on forever, right? So that's another portion. So I can just kind of go ahead and label that. So the idea is we want to pick a number between negative infinity and negative 2. And we already know that negative 2 is going to satisfy this inequality because it's less than or equal to 0. So we don't really have to check negative 2 because we already know that it's included in the interval, right? So if I have negative infinity to negative 2, I'm going to pick a point between those two. I'm going to pick an x value between those two. And I'm going to say, for example, x equals negative 3, right? So if I pick x equals negative 3, I'm going to test it out to see if it satisfies this inequality. So this ends up being, it's going to be the quantity negative 3 minus 9, negative 3 minus 9, and then times negative 3 plus 2, times negative 3 plus 2. And I'm going to say, is this less than or equal to 0, right? So is this less than or equal to 0? So then I have negative 12 times negative 1 is less than or equal to 0. And then negative times negative is positive, so we have positive 12 is less than or equal to 0. Notice that I do not change the inequality because I do not flip it over because there is nothing being multiplied over here by a negative. If there was being something multiplied by a negative number on both sides, then I would flip it over. But just because there's two negatives being multiplied here, you keep the inequality symbol the same. I just want to make that very clear. Okay. So then I have 12 is less than or equal to 0. Now you would ask yourself, is that true, right? Obviously, this is not true. 12 is not less than or equal to 0. So we can't use negative infinity to negative 2 because that's not going to work, right? Now, obviously, we know that negative 2 is included. So the next one that I'm going to pick is, so we obviously know that the blue part can't be shaded, right? So we can't use that. And now the next part will be from negative 1 to 9, right? So, or I'm sorry, from negative 2 to 9, right? So my next one will be negative 2 to 9. And I can pick x equals 0, right? Because that's between -2 and 9, right? I can pick that point. So I'm going to go ahead and put that in. So x equals 0. So I have the quantity 0. So it's going to be 0 minus 9 times the quantity 0 plus 2 is less than or equal to 0. So then I have -9 times 2 is less than or equal to 0. -18 is less than or equal to 0. This is true because obviously a negative is less than 0, negative number. So I can say that -2 to 9 can be one of the inequalities that can be, that one of the intervals that we can pick, right? So this works. This works. Now what about 9 to infinity? So I can, again, use 9 to infinity, and I can pick a number that is between 9 and infinity, something greater than 9, right? Obviously, I'm not going to pick 9 because, like I said, it satisfies the inequality. It does because it's less than or equal to 0, right? So I have, let's do x equals 10, right? So we have the quantity 10 minus 9 times the quantity 10 plus 2 is less than or equal to 0. This is 1 times 12 is less than or equal to 0. So obviously this is not true. It's not less than or equal to 0. So I can't use that as my answer, right? I can't pick this one. So I would say this does not work, right? So now the only one that works is from -2 to 9, right? Or I'm sorry. No, yeah, from -2 to 9. And that would be the only one that, would satisfy this inequality, right? So I would say that my answer is from -2 to 9. Now to graph it, obviously I put, don't get confused by this, guys, this does not belong here. I put that to show you guys what point I was picking between -2 and 9. So now to graph it, all you have to do is just like, we have the endpoints at -2 and 9, so now all we have to do is just shade it in between, right? Like that. And then in interval notation, the answer would be from -2 to 9, like this. Okay. So that is how you do this problem, guys. If y'all have any questions about this, please let me know. I know it was a little bit longer, but yeah. So that's how you do a problem like that when you're given a problem that is in standard form, and you have to literally factor it and use the rules of quadratic inequalities to solve it. So like I said, if you guys have any questions, please let me know. Also, please like, comment, and or subscribe. And also, thank you so much for watching, guys, and I will see y'all in the next video. Bye, guys.